For millennia, humanity has looked to the stars with wonder and ambition. The night sky, with its countless stars and celestial wonders, has always been a source of inspiration and curiosity. Ancient civilizations built monuments aligned with the stars, navigators used them to traverse the oceans, and poets and philosophers pondered their mysteries. The stars have been our guides, our muses, and our dreams. We have dreamt of exploring the cosmos, unlocking its secrets, and harnessing its vast potential. The journey from the first telescopes to the powerful space observatories of today has been nothing short of extraordinary. Each step forward has brought us closer to understanding the universe and our place within it. The launch of spacecraft, the landing on the moon, and the exploration of distant planets have all been milestones in our quest to reach the stars. Today that dream is closer than ever as we stand on the cusp of a new era, the age of asteroid mining. This new frontier promises not only to expand our horizons, but also to provide us with the resources needed to sustain and advance our civilization. The technology to reach and mine asteroids is rapidly developing, and what once seemed like science fiction is now becoming a reality. Imagine a future where the resources of space fuel our industries, power our cities, and enable us to reach new heights of technological advancement. Solar panels in space could capture the sun's energy more efficiently, and space stations could serve as hubs for research and development. The possibilities are endless, and the impact on our daily lives could be profound. From reducing our dependence on Earth's finite resources to creating new economic opportunities, the benefits of space resource utilization are immense. This is the promise of asteroid mining, a prospect that has captured the imaginations of scientists, entrepreneurs, and dreamers alike. The collaboration between these visionaries is driving innovation and pushing the boundaries of what is possible. Engineers are designing advanced robotic systems to extract and process materials in space, while entrepreneurs are developing business models to make space mining economically viable. The dreamers, those who see beyond the horizon, are inspiring us all to believe in a future where space is not just a destination, but a resource. The potential rewards of asteroid mining are nothing short of astronomical. Asteroids, often considered mere space rocks, are treasure troves of valuable materials. These celestial bodies formed during the early stages of our solar system have remained largely unchanged for billions of years. They hold the keys to understanding the building blocks of planets and the origins of life itself. Asteroids, rocky remnants from the early solar system, contain a staggering abundance of valuable resources. These resources are not just limited to metals and minerals, but also include water and other volatiles that are essential for life and space exploration. The asteroid belt, located between Mars and Jupiter, is home to millions of these objects, each with its unique composition and potential. These include precious metals like gold and platinum, which are rare and highly sought after on Earth. The abundance of these metals in space could lead to a new era of wealth and prosperity. Mining operations on asteroids could extract these valuable resources and bring them back to Earth, significantly impacting global markets and economies. Industrial metals like iron and nickel are also found in abundance on asteroids. These metals are the backbone of our industrial society, used in everything from construction to manufacturing. Accessing these resources in space could reduce the environmental impact of mining on Earth and provide a steady supply of materials for future technological advancements. And even water ice that can be used to generate rocket fuel. Water is a critical resource for life and space exploration. By converting water ice into hydrogen and oxygen, we can create rocket fuel, enabling longer and more sustainable space missions. This capability could transform space travel, making it more efficient and cost-effective. These resources, if harnessed effectively, could revolutionize our world and pave the way for a brighter future. The successful extraction and utilization of space resources could lead to technological breakthroughs, economic growth, and a new era of exploration and discovery. As we stand on the brink of this exciting new chapter, the possibilities are as vast as the universe itself. The asteroid belt, a vast ring of celestial bodies orbiting the Sun between Mars and Jupiter, is one of the most intriguing regions of our solar system. This cosmic neighborhood is not just a collection of random space rocks. It represents a treasure trove of cosmic resources waiting to be explored and utilized. The asteroid belt is a region filled with countless asteroids, each with its own unique composition and characteristics. These celestial bodies vary greatly in size, shape, and material, making them a fascinating subject of study for scientists and astronomers alike. This region of our solar system is home to millions of asteroids, ranging in size from small boulders to dwarf planets hundreds of kilometers across. Some of these asteroids are composed of metals like iron and nickel, while others contain water, carbon, and even precious metals like gold and platinum. Scientists estimate that the asteroid belt contains trillions of dollars worth of valuable metals and other resources. The potential economic benefits of mining these asteroids are staggering, with some estimates suggesting that a single asteroid could contain more resources than have ever been mined on Earth. This makes it an incredibly enticing target for future mining operations. The development of advanced space mining technologies could revolutionize our approach to resource extraction, providing a virtually limitless supply of materials for use on Earth and in space. These asteroids are not just valuable for their composition, they also offer a unique opportunity to study the early solar system. By analyzing the materials found on these ancient space rocks, scientists can gain insights into the processes that shaped our solar system billions of years ago. Their location also makes them relatively accessible. Unlike distant planets or moons, the asteroid belt is situated in a region that is easier to reach with current space travel technology. This accessibility opens up new possibilities for exploration and exploitation. Unlike the Moon or Mars, which require considerable effort to reach, the asteroid belt is relatively close to Earth in astronomical terms. This proximity means that missions to the asteroid belt can be shorter and less expensive, making it a more practical target for exploration and resource extraction. This proximity reduces travel time and lowers the cost of missions, making asteroid mining a more feasible endeavor. As we continue to develop new technologies and strategies for space exploration, the asteroid belt could become a key player in our quest to harness the resources of the cosmos. Among the countless asteroids in the belt, one stands out as a particularly alluring target: 16 Psyche. This massive metallic asteroid, named after the Greek goddess of the soul, is believed to be the exposed iron-nickel core of a protoplanet. What makes 16 Psyche truly exceptional is its sheer size and composition. With a diameter of roughly 226 kilometers, it is one of the largest objects in the asteroid belt. Scientists estimate that the iron alone contained within 16 Psyche could be worth an astronomical $10,000 quadrillion. That's a 1 followed by 19 zeros. And that's just the iron. 16 Psyche is also thought to contain significant quantities of nickel, platinum, and other precious metals. The potential wealth represented by this single asteroid is simply staggering. Section 4. Reaching for the stars. Mining the cosmos. Mining asteroids in the depths of space presents unique challenges, requiring innovative technologies and approaches. Currently, several promising methods are being developed to extract resources from these celestial bodies. One such method involves robotic mining vehicles. These sophisticated machines, controlled remotely from Earth, would be capable of landing on asteroids and extracting valuable materials. The extracted resources could then be transported back to Earth, or used to construct infrastructure in space. Another exciting possibility is the development of space-based factories. These orbital facilities would process raw materials extracted from asteroids, transforming them into usable products without the need to transport them back to Earth. This would significantly reduce costs and increase the efficiency of asteroid mining operations. Section 5. Space Law. Who owns the final frontier? The prospect of extracting resources from space raises complex legal and ethical questions. As humanity looks beyond Earth for new opportunities, the idea of mining asteroids and other celestial bodies becomes increasingly appealing. These space resources could potentially provide rare minerals and elements that are scarce on our home planet, fueling technological advancements and economic growth. However, the legal landscape surrounding space mining is murky and fraught with challenges. The Outer Space Treaty of 1967, the cornerstone of international space law, prohibits nations from claiming sovereignty over celestial bodies like asteroids. This treaty, signed by over 100 countries, was designed to ensure that space remains a domain for peaceful exploration and use by all humankind. It establishes that outer space, including the moon and other celestial bodies, is not subject to national appropriation by any means. However, the treaty is less clear on whether private companies or individuals can claim ownership of space resources. This ambiguity has led to a growing interest in revisiting and potentially revising space law to address the realities of modern space exploration. Private companies, driven by the potential for profit, are investing heavily in technologies that could make asteroid mining feasible within the next few decades. This ambiguity has led to debate over the legal status of asteroid mining. Legal scholars, policymakers, and industry leaders are engaged in discussions about how to balance the interests of private enterprise with the need to preserve space as a global commons. Some argue that without clear regulations, the rush to exploit space resources could lead to conflicts and environmental degradation, similar to issues faced on Earth. Some argue that space resources should be considered the common heritage of mankind, accessible to all nations. This perspective emphasizes the importance of international cooperation and equitable sharing of the benefits derived from space exploration. Proponents of this view believe that space should be used to advance the collective interests of humanity, rather than being dominated by a few powerful entities. Others contend that private companies should be free to extract and profit from these resources. They argue that allowing private enterprise to operate in space will drive innovation, reduce costs, and accelerate the development of space technologies. By creating a competitive market for space resources, they believe that humanity can achieve greater progress and unlock the full potential of the final frontier. As asteroid mining moves closer to reality, establishing clear and equitable legal frameworks for space resource ownership will be crucial to prevent conflict and ensure that the benefits of space exploration are shared by all humankind. The international community faces the challenge of crafting policies that balance the interests of nations, private companies, and the global public. By addressing these issues proactively, we can pave the way for a future where space exploration contributes to the well-being and prosperity of all people on Earth.